Okay, so we built the pyramid. Actually, move the triangles out of the way. All right, so now we may have to work on the whiteboard a little bit. So pull that back towards you.
Okay.
Now we found that the yellows didn't quite make the exact right height for our pyramid here. That's fine.
Yeah.
Yeah, but we could use this as an approximation.
Yeah.
We can try
For-
to calculate it.
How would we calculate the height of this pyramid?
Well-
What would we do?
I have an idea.
Okay.
So we know, well, I know that the pyramid touches this base triangle at the circumcenter
Okay.
of it.
So that's the center of that equilateral triangle.
Yes.
That's where the pyramid touches it. Okay.
So if we draw this right triangle, should I draw upside down?
Yeah, go ahead. That's fine.
Alright, I'll draw right side up and draw it upside down. So this right triangle where this is the height, this is this distance from here to here,
Okay.
call that x, and then
Right.
this is 2 root 2. And we don't know anything much about x or height.
Okay. Yeah.
Actually,
Interesting.
so that,
Well, how are we going to figure it out?
well, x is the circumradius of the circle, of the circumcircle, but doesn't really help us. Though I see something maybe we can do.
All right. What would you like to try?
So we can chop an equilateral triangle. So we chop an equilateral triangle using the midpoints of the sides and this point.
Then you'd get 4 smaller equilateral triangles. If you split it.
Now if you split it like this, you have 6 congruent right triangles.
Oh,
Mm-hmm. I know
And
these are right triangles,
Yep.
so that's the height.
very good.
so
Very good observation.
And we know also that these are 30, 60, 90 triangles. Because
Oh.
each of these angles is 30 and this is 60.
Because this is that's okay. Don't worry about moving the board around. In fact, pull it back towards you now.
Alright.
Okay. So that's interesting. So what do we know? How can we find out some of those distances now?
Well, we know that this is the midpoint of the sides.
Okay.
This is root 2.
All right. Why is it root 2?
Because the greens are root 2.
The greens are root 2.
Yeah.
Okay.
And
Do we know?
so since it's a 30, 60, 90 triangle,
Well, hold on. Draw the 30, 60, 90 triangle all by itself now. Okay, so the long side, the side opposite the 60, is the square root of 2.
Yeah.
Okay. So what does that mean? Do you remember what that means about the short side? Can you grab the 30, 60, 90 model we had? So if the long, what's the relationship between the long side and the short side?
I think it was the golden ratio.
How long is that long side? How long are those two yellows?
These, well, those are, wasn't that root 3?
Yeah, how long is the short side?
That was 1.
We're on 1, so we go from root 3 to 1 from the long side to the short side. So we just divide by what?
Root 3.
Okay, so what's the short side of our triangle here?
so it's 2, it's the square root of 2 over the square root of 3.
Okay, and what's the relationship between the short side and the long side?
Well, let's see, well, the long side is 2,
Okay,
and the short side is 1.
so what do we have to do?
Well, it's the square root of 2. The square root of 2 over the square root of 3 times 2.
2 times the square root of 2 over the square root of 3. Okay, and what's the long side, going back to your other picture? What side were we interested in finding out? What length did we
It
need
was
to
this
know?
side that we needed to know.
And what side of the
That's
triangle
2
is that?
root 2 over
That's
square
that
root of 3.
side.
Okay, great. Would you just, in the pyramid there, just grab that green stick here and put that in, let that be that side, even though it's not really, it just helps us see the triangle.
Yeah, couldn't
It's not really the right length, but it helps us see the triangle.
So
So what do we know now?
now we can draw this triangle again.
Okay, go ahead and do that.
So,
Oh, actually, you know what, we're at 5 minutes, so
okay.
I'm gonna turn the camera off. Why don't you erase the board?